Hello math students, I've had a request for another example of the Gauss Jordan Elimination, so let's jump right into it here. Alright, so we're looking at the system of equations. X plus 4y minus 2z equals 9, x plus 5y plus 2z equals negative 2, and x plus 4y minus 28z is equal to 21. So of course the first thing we want to do is put it into that augmented matrix. 1, 4, negative 2, and then that vertical line augmenting the answers, so 9 on that side. 1, 5, 2, negative 2, 1, 4, negative 28, and 22. So basically we're just taking the coefficients of the variables, keeping the columns lined up, and writing them down there. And so what we want to do is, our goal again is the identity matrix, and I like to go through it and try to work that first column first. I want to get the 1 in the upper left hand corner and then the zeros down below it, trying to get to that sort of format. And I see that I've got a 1 here in the second row, and so I've got a 1 in the first row, so if I multiply the first row, I'm going to take negative 1 times row 1, add it to row 2, and put it in a row 2 spot. So negative 1 times row 1 would give me a negative 1 that if I add it to, well, I'm going to leave the first row the same. Let me copy that down to start with. I'm going to take a negative 1 plus 1, that's going to give me 0. Negative 1 times the 4 plus the 5 gives us 1. Negative 1 times negative 2 is a positive 2 that when I add to the 2 in row 2, I'm going to end up with 4. And then I'm going to get a negative 9. Negative 1 times 9 is a negative 9. Plus negative 2 is negative 11. So we've got to be careful with our arithmetic there. Sometimes it kind of helps to do different things there. So I've got the 1, the 0, and then I've got that bottom row to fix. I'm going to do it here at the same step as well. I need to get that 0 in the bottom row. I've got a 1 in the first row. I'm going to multiply the 1 in the first row times negative 1 and add it to the third row. So I'm going to do negative 1 times row 1 plus row 3 and see what that gives me. Now sometimes it's kind of nice to write these out on the side just to help with your arithmetic. If I take negative 1 times row 1, it's negative 1, negative 4, positive 2, negative 9. And then row 3 is just 1, 4, negative 28, 22. And so if I add, well, that's 0. Oh, negative 4 and positive 4 is 0. That's nice too. 2 and negative 28 is a negative 26. And 22 minus 9 is 13. So that bottom row will become 0, 0, negative 26, 13. All right, that's good. So now my next goal is to work on that second column. I want the 0 in the first row, a 1 in the second row, and a 0 in the third row going down that second column. I've already got the 1, I've already got the 0. That worked out really nice, but I'd shoot for the 1 first, try to get a 1 in that first spot, maybe divide through by something to get a 1, something along those lines, but I'm going to try for that 1, 0, and I've already got the 0 underneath it, so I need to get rid of the 4 right in the first row, second column there. So let's do negative 4 times row 2 and add it to row 1. Negative 4 times row 2 and add it to negative 1. If I take row 2 and I multiply it by negative 4, I'll get 0, negative 4, negative 16, and positive 44. And row 1 is 1, 4, negative 2, 9. And so when I add those two together, I will get 1, 0, negative 18, and 53. And that's going to be my new row 1. I'm going to put that in row 1 spot. Row 2 is going to stay the same, and I don't have to do anything to row 3 because it already has the 0 in the second column where I need it. Alright. So next I'm going to work on the third row. I want to get the 1 in the bottom right hand corner there, and then, or third column. I want to make 1 in the bottom right hand corner and then zeros up above that. And the way I can do that, I've got a negative 26. What I'm going to do is I'm going to multiply by negative 1 over 26 times row 3 and put that back into row 3 spot. I'm going to basically divide everything in row 3 by negative 26. And the other rows are going to stay the same for a minute. And then, whoops, negative 26 divided by negative 126 is going to give us just negative or positive 1. And then let me get rid of that positive sign. That's going to be confusing later on. And then 13 divided by negative 126. Well, that reduces nicely. It's minus 1/2. 13 is double 26. Okay, so I got the 1 there. And now I need to make the zeros above that. So if I can do, let's just start with the first row. If I take 18 times row 3 and add it to row 1, and I'm going to put the result back into row 1 spot. So 18 times row 3, whoops, that's not going to be a 0. 18 times 1 is 18, and 18 times minus 1/2 is negative 9. And I want to add that to row 1, 0, 1, 0, negative 18, 53. And you can kind of see why I really like to have these zeros over here, because it's not changing that first column. 0 plus 1 stays 1. It doesn't change the columns that I've already fixed there. That 1 in the upper left-hand corner is going to stay a 1. 0 plus 0 is 0, so that's going to stay 0. 18 and a negative 18 is 0. And 53 and a negative 9 is a positive 44. All right, so that first row is 1, 0, 0, 44. Let's see, the bottom row is perfect the way it is. Let's go ahead and fix the middle row. And I need to get rid of the 4 here in the second row, third column. So I'm going to take negative 4 times row 3 and add it to row 2 and put the result back into row 2 spot. So negative 4 times row 3 would be 0, 0. 1 times negative 4 is negative 4, and negative 4 times 1/2 gives me a positive 2. And then 0, 1, 4, negative 11. And as you add, 0 plus 0 is 0, keeping a 0 here in that first column. 0 plus 1 is 1, keeping the 1 right there in the second column. Negative 4 and positive 4 make 0. And 2 plus negative 11 is a negative 9. So there we have our row reduced matrix. That's as far as we can go. And our first column again was the X column. It's got the 1 that lines up with 14, so I know that our X is equal to 44. Not 14, X lines up with 44. Y equals negative 9, and Z equals minus 1/2. And that would be our solution. If we want, we could go back and check these in the original equations, make sure they work out. I'm sure that they do, but might be something to check if you want to do that just for fun.